So thank you again for coming. And if you could tell us the work for which you were recognized for the Fields Medal.
Yeah, and so probably mostly it's hard to explain to non-specialists, but it's in the theory of Lie groups and discrete subgroups. So probably the main result which I was recognized for, it's proof of arithmeticity of lattices in higher rank groups. So it's probably, I don't want to translate this thing. but it was quite outstanding problem for quite many years, which was approached by quite a few outstanding great mathematicians, and DNVA, Selberg, and others.
And in what year did you have your breakthrough, your big discovery?
Yeah, no, so actually I worked on this problem for quite many years. Probably the final was something like in 1973, 74. Mm-hmm. So when I was 27, 28.
And then you won the award in which year?
In 1978 it was.
Okay.
I was 32.
Mm-hmm. Well, let's go back a little bit. What was your training before that, and how did you become interested in the problem?
In what? In problem or in mathematics?
In the subject that of Lie groups.
No, I was educated at Moscow State University in a department that's called, actually it was called Fakultet of Mechanico-Mathematiический facultet, which can be translated Faculty of Mechanics and Mathematics, but probably faculty means in English different than in...
Department, perhaps.
Yes, yeah. It's not a department actually, it's the entire section of, so it were probably number of students each year was for both mathematics and mechanics was undergraduates for 150, which is, in mathematics probably 250 and mechanics 200, so it's, so it's not a department in, say, an American sense, or maybe
it was a larger group. It was like a
college.
It's
a large group, and also it's kind of autonomous part.
Mm-hmm. And let's go back a little further. What got you interested in mathematics in the first place?
Yeah, so actually, so my father was a mathematician, and somehow he encouraged me to do mathematics. So he was actually he was a graduate student of a famous mathematician in probability, Hintgen, but my father was mostly interested in education and mathematics, and he, under the supervision of Hintgen, he wrote a thesis and a dissertation in education of mathematics. And he somehow encouraged me to do mathematics for quite early age, maybe 6, 7, 8. And then after that I attended, there was a system of mathematical circles starting from my 7th grade, which I was 12 or 15, and then for several years I attended this, and then also I participated in mathematical Olympiads. And so actually at that time it was probably 1957 until 62 when I became a student, undergraduate student then.
And your talent was recognized early, I assume?
Yeah, actually I got some prizes at this Olympiad, and actually maybe last year got first prize. And then I was a participant of the, maybe have some water.
Yeah, sure. Still or sparkling?
Still, maybe.
I think, is this still? I think,
Yeah.
Okay.
It was a participant in International Olympiad in 1962 in Czechoslovakia.
And then
And then when I started to be students, so at that actually the system was actually the undergraduate students were involved and research started maybe quite early, so it was probably the first, second year, third year, and then I actually published my first paper it was published in 1966, but I did it when I wrote this, 1965, it was 19. And actually it was not unusual to write papers, research papers for at quite early age in Moscow. So it's not that everybody did that, but I was not an exception. At least, so probably quite many people did that.
was there anybody, after you left home, of course your father was your mentor at home, but when you went to the university, was there anyone in particular who you felt...
Yeah, so there was also, I attended many seminars. But my advisors started probably third or fourth year of it was 5 years of undergraduate, and maybe starting third or fourth year, maybe third year, it was Sinai who, actually he got an Abel Prize.
What was his name?
Yeah, Sinai.
Sinai.
He got an Abel Prize in 2014. I don't know if but he didn't attend this.
Wow.
And then it also was influenced by many other mathematicians. And actually in the subject of discrete subgroup of Lie groups and this problem of arithmeticity was mostly influenced by Petetsky Shapiro, who was a famous mathematician in Moscow, but then he moved to Israel and the United States in 1976. He got a Wolf Prize, which is quite one of the prestigious prizes. Also, I got it, but in this prize I got in 2005.
So you had recognition quite early, and I imagine that made people look up to you and treat you as a mentor actually at a fairly young age.
No, actually while I was in Moscow, so after graduation I went to this, after there was undergraduate, then there was graduate students for 3 years, and then I went to Institute for Problems Information Transmission, which was one of the institutes of the Soviet Academy of Sciences. By the standards of that time in the Soviet Union, it was a relatively small institute, so only 200 people. But I was in some kind of, it was some mathematicians, some engineers, some biologists, but my mathematical part was mostly, there's 2 labs, so maybe 30 or 40 people. And there I did some, probably actually the best known my work is on expanders, which is a quite fashionable subject in theoretical computer science.
Expanders?
Yes.
Okay.
Yeah, probably if you interviewed, there's Dan Spielman.
I did.
Yeah, and so he did some interesting work on expanders, and I actually quite, No, probably it's not my best work, but but because it's many people from other fields were influenced by that, and then so then I worked on this problem, which is encouraged by several people, but mostly by Petetsky Shapiro, and then after certain.
And this is when you were still a student, or were you?
No, this was not when I was a student. No, okay. It was later.
And you were a professor, right?
No, I was not a professor. No, it's the Institute for Information Transmission was a research institute. I was a, hard to translate. Okay, maybe. Research, старший научный сотрудник, research fellow, senior research fellow, junior research. Okay, it's hard to translate. If you translate just literally, it will look quite funny. So it's and then so probably that's in 73. That's when I was already at this institute. But before I left the Soviet Union, I essentially didn't have graduate students. So I had one, but it more or less kind by accident, who was, and actually it was not completely formal, but it was something formal, but it's kind by accident. But after I moved to the United States, became a professor at Yale. So it's.
What year was that?
I moved, I became professor at Yale in 91.
91, okay.
And so I have been there for 28 years. And during this period, I had approximately 20 graduate students, maybe a little bit more.
Is this your first time? This isn't your first time at the HLF, is it? No,
it's my second time.
It's your second time.
I told you that.
That's right.
I was last year.
Last year. So you're getting a lot of exposure to young researchers here, all of a sudden.
No, actually here maybe not so many.
Really?
No, because here mostly people which are in computer science. And I don't know, actually it was not so much. There are some, but not.
Now, since you, as you said earlier, your research is in a very technical area, do you find that the researchers here have an appreciation for what you've done?
No, but it's okay. So there was people in computer science. Okay, they probably. No, okay. At least some of them know me mostly for this work on expanders.
Ah, yes.
And for them, which what I told you about is maybe quite abstract, and so it's quite okay. It's very different than what they were doing, but there are not so many mathematicians. Last year there was about 10.
Who you felt understood and appreciated.
But there were 10 mathematicians for Fields Medal and
yes, of the
and
Laureates.
this year there's only 4.
Ah, okay.
And so probably they know what I did, but it's.
I know it's only Monday. Have you had any especially interesting discussions with the researchers?
No, actually there was during this reception I was approached at least by one student who did something work which is maybe related to what I was doing, but so also some kind of social interaction with some other people.
Yeah. Getting back to your work, and I know that, as you say, perhaps you don't want to explain all the details of it, but let's talk about sort of what it was like before before your paper and award, and then after and what it is today. And I understand you might have to get sort of technical about the details, but let me know sort of what the progression is of thinking around Lie groups.
No, it's Yanis. So it's Yanis Lie groups. It's quite a very big subject, and so probably it's very discrete. So I proved this arithmeticity, and that was the main part was proof of so-called superrigidity. Then it's because of work of some other mathematicians, in particular Zimmer. Somehow it was done for something in dynamics, and then some applications in many fields, and including logic, quite unexpectedly. And so then it's so it was quite influential, but in Lie groups it also was. So it's not exactly, not only in Lie group theory, but also some other fields.
Are there interesting things happening in your field now?
Yeah, so it's, now I became mostly interested in so-called homogeneous dynamics. It's which is also has applications to number theory, and actually it's related, maybe not very directly what I was doing in discrete subgroups of Lie groups, but there was some technical parts.
Don't be afraid to say that. I might not understand it, but perhaps some of the viewers.
But something which is kind of dynamics, some statements, and then it can be that it will imply some results in number theory. Actually, one of the things which I did in mid-80s, it was proof of so-called Oppenheim conjecture, which is about irrational quadratic forms. But actually it could be stated, some special statement that, for example, if you have an inequality x squared plus y squared minus square root of 2 multiplied by z squared, then the absolute value of, and you take the absolute value of this, then it's for every epsilon, if you take this absolute value, that this absolute value less than epsilon, then this inequality has infinitely many integral solutions. So x, y, and z are integers. So there are infinitely many triples of integers x, y, and z, such that absolute value of x squared plus y squared minus square root of 2 multiplied by z squared. So absolute value of all this expression is less than epsilon, has for infinitely many triples, it has a solution. So it's.
This is a recent.
No, it's 20 years ago. Okay. Yeah, and then somehow there was quite many. And then in direction of this, it's using homogeneous dynamics, and there were many other applications of homogeneous dynamics to number theoretical problems. It's maybe not exactly about quadratic forms, but for some other number theoretical problems.
I'd like to switch a little bit to the HLF itself. So this is your second time here.
Yes.
So what is it that drew you back? What have you enjoyed about it?
Yeah, it's quite maybe to meet some people, and actually this year somehow there's I just started. It was quite interesting talks, and tomorrow will be some discussion about climate change, and then it's other topics. So it's.
I think last year was artificial intelligence was the subject, wasn't it?
I'm not sure. Yeah, no, so they were quite.
I think so, yeah. There's a lot of artificial intelligence happening this year because Yoshua Bengio won the prize and Shwetak Patel, they're both AI-type people.
Yes.
Yeah. Have you had much, now you mentioned, actually let's talk a little bit more about expanders because since there are so many of the computer science people here this year, and you say that more people understand that, could you describe sort of what that is?
Yeah, no, so expanders, okay, you have some graph, finite graph, and which is regular. So it's non-oriented graph. From every vertex there is a, say, from every edge there's exactly D edges.
A directed graph?
Non-oriented.
Okay.
And then it's, if you somehow you want, if you take some subset of vertices, which is, so number of vertices, say n, and if you take less than half of them, then they're connected to, so n over 2, and then they're connected to maybe more n over 2 multiplied by 1 plus some positive number. But actually it's kind of asymptotically, so it's every set expands to
some point,
to
some limit.
To something more.
Yeah.
Yeah, no, so it's quite easy to prove existence using some random graphs, and this the notion of expanders was introduced by Pinsker, who was a senior person at the Institute of Problems Information Transmission. He was born in 1925, so he was a head of one of these two labs. Not where I worked. My boss was Dobrusin, but and he introduced this notion of expander. Actually, it was some ingredient in the construction of so-called concentrators. So maybe a concentrator less known now among experts, but somehow expanders, and actual notion, somehow it was a very well-defined notion, expander. And actually, and then what I did is I gave an explicit construction. So it...
Of expanders?
Yeah, of expanders.
Yes.
So it's relatively easy to prove by probabilistic methods existence, and actually almost all. In some set of graphs, so it's quite easy to show that almost all of them are expanders. But nevertheless, it's to give an explicit construction, it was difficult. And I used an actual method from discrete subgroups of Lie groups somehow.
Oh, so the two actually did...
yes, and this is... In some sense, it was for me, it was kind of byproduct, but...
Was it an expected intersection of those two?
No, probably not.
Yeah.
Actually, I think I was told somehow people from computer science were quite impressed that something from very abstract can be applied to this. So now it's somewhat standard, but yeah, and then and so also relatively recently somehow it was realized that maybe something related to expanders was in somewhat early work of a great mathematician Kolmogorov and one of his co-author Barzin, and they did some, motivated by some kind of models of brains, but yes, so it's in some sense they want to put some model of brain in some certain volume, and so that as much as possible, and there's a sum upper bound, lower bound, and then for some best, somehow this graph should be mostly on the border of brain, so it's maybe somehow it gives some kind of explanation why cortex is on the surface, not inside. But it was, but somehow it was quite strange. Somehow there was something which is related to expanders actually, but people who, there was Pinsky, Basalega was a student of Kolmogorov. Actually, at that time, and even for 40 years, they didn't pay attention to this paper by Kolmogorov, and Kolmogorov somehow didn't complain and didn't know about expanders. So it's somehow maybe it was this notion was in the air, but it's
funny when you mentioned that Kolmogorov's paper wasn't appreciated for many years. It sort of makes me...
Yeah, but maybe it was... so it's... maybe it was published. Somehow it was not...
Well, back in those days, in the days of the Soviet Union, how much of a split was there between the Soviet mathematics and the Western mathematics?
Not quite a big. So it was. So it was very difficult to travel, and was especially to the West, and actually was quite elaborate procedure to get the permission, which is, for most it was really impossible. And
did you have access to papers?
No, the papers was access.
Yeah. And to the outside, was the Western world?
Western world also had. It was it was published in the Soviet Union, in Russian, and then it's people usually didn't know Russian, and then it was in best journals it was translated into English, but at that time there was no any kind of internet, of course, and then it could be several years after it was published in Russian, and then it was in English. So it's, and actually because of them, maybe as papers of Soviet mathematicians were not less recognized than they deserve. So also there was, it was very difficult to send kind of preprint. You also have to get certain permissions, and also personal interactions were very limited. So some Western mathematicians came to the Soviet Union, but not many. Now, of course, there was an international congress in 1966 in Moscow, but which was attended by many, but then it's, for example, I didn't get the permission to receive my Fields Medal to get to the Congress in 1978.
Really?
Yes.
So you received it in absentia. You weren't there.
No, I received. No, I was awarded, and then, also there was procedure to kind of accept the award, which is somehow I passed, but then in 78, so there was a Congress, and there was delegation of Soviet mathematicians, and then I was not included in the delegation, but actually it's somehow it's not exactly by the government, but by so-called certain part of mathematical establishment. So it's
the officials of mathematics.
no, there were some mathematicians, outstanding mathematicians, but somehow it was. So in a sense, I was not recognized as kind of professional mathematician by certain part of
That's interesting. For political reasons?
No, it depends what you call political reasons.
Let's check the time. It is a little bit after 4:30. I don't know if you need to
No, it's
go
okay.
now. Okay, good. If you don't mind, I'll just because this is a very interesting subject. When did you actually end up coming to the United States?
No, so actually going back about.
Oh,
so in 1979, actually, I got the permission to travel to. I went to Bonn for 3 months on the invitation of Hirzebruch, and then somehow it was arranged, and I got a Fields Medal. So there was a relatively small ceremony in Bonn, and Jacques Titz came and brought this medal, and the check, which was pretty small, 1,500 Canadian dollars. No, actually, Fields Medal now it's 15,000, but it's certainly not a huge amount. It's mostly prestige.
It's not MacArthur Grant money.
Yes, and also not
Turing Award money.
Now Turing Award is 1 million.
I think it is, yeah.
It started from what?
It was $250,000 for a while, I think. And now, then Google, I think, put in some money.
Yeah, imagine before a quarter, it was probably pretty small. Also, yeah, but and then I moved to the. So after 86, 87, it was much easier to travel to the West. But then, in 91, I went for 1 year was at Harvard and the Institute for Advanced Study. No, in 1990. Was 1 semester at Harvard and several months at the Institute for Advanced Study. In 91, I became a professor at Yale.
We probably should wrap it up here. Do you have any final thoughts that you'd like to say, either perhaps to young researchers?
No, probably.
Okay.
Okay.
Thank you so much for the time. I appreciate it.